All right, so there are a few more things to talk about in terms of hypothesis testing. One is just a quick review of what the heck our p-value actually is. So this is the extra credit discussion board for week 11, was this reading some of the articles that had come out in support or giving alternatives to a p-value, because there was a journal that basically outlawed p-values, so the American Statistical Association made a statement, and then a lot of different people chimed in. So our p-value, I think the easiest way to understand it is in the context that we've seen it before. So we've had three different contexts that I think sort of solidify things. One was joy, when we were talking about smelling Parkinson's, right? So our p-value was when we all put our little dots on the board. And then we had joy over here at 11, and then eventually we find out that she really was at 12. Our p-value is a probability of getting out 11 or more shirts if she was just guessing. And we could even go further now. We could even put some hypotheses to that. So in this case, the proportion, or the proportion of her correctly guessing what the shirt was, our null was that it was 50%, but our alternative was really that she was doing better than guessing, right? That she could tell. So there's this idea in hypothesis testing that we're always dealing with a conditional probability, and it's always about given the null hypothesis being true. So that's why we have to assume innocence in the court case example, and then we say, okay, is there enough evidence with that assumption, right, our starting point, that this is true? So we also saw this in the racism in the South question in the 50s and 60s, when we had that one example with the juries. We started with, okay, well, let's assume, right? Let's assume there is no racism in the South, and that the proportion of African Americans being selected for juries is the same as the proportion of African Americans in the population who are eligible for jury service, that it's 50%. So we went and we put our sampling distribution right at 50%, and then we said, oh, well, we took a sample and we got out 5%. How unusual is this, right? What's the probability of this happening if we're centered at 50%, if they're not actually discriminating, right? And same thing with the coin flipping example. There's all sorts of examples we've done, but it's always about this idea that if this is true, if we can center our distribution at this p, what's the probability of getting what we observed? So you have that written a little bit more mathically down here below. Basically, it's a probability. In this case, our p hat is more extreme. Than what was observed, given p is actually equal to our null value. So you always want to see your p hat here in the probability, because that's the thing that we're setting there, right? This is our p hat, and we always have our null value centered at the middle. So go ahead, take a stab at exercise 1, and then come back. So in exercise 1, our null is that p is 0.64. So that's our initial assumption. That's where we're going to center our distribution. That's what we're conditioning on. So what we need is an answer choice here, since we're looking for the p-value, an interpretation of that. We need to find something that says if p is really 0.64. If 64% of Americans really feel like they were overdue for a promotion. So if really 0.66, well, that's the other way around, right? So this is saying if p is equal to 0.66, that's the wrong direction. I don't know why I skipped that. If population proportion is really 0.64, okay, there's our conditional. There's a, okay, 0.0537 probability that the sample proportion could be greater than 0.66. So here we can see 66% was our value from our sample, right? That's our p hat. So that's what we got. We want to know, is that so different than 64%? we have a right-tailed test, so there's the probability that we'd be looking for, and they told us that this is 0.0537. So our answer is A. And to look at those other wrong answers, B is just too simple. There's a probability the population proportion is 64%. That's just not complicated enough. That's a very common misconception because students want it to be that direct and like, oh, it's a low probability, so this is probably unlikely. But it's always about the observed value because the population proportion is a set value. We can't have probabilities or randomness associated with that. All right.